Good old matrix multiplication. Something I hadn't done in a minute. All right, so what are we doing here? We're supposed to find the product of A and B. And A is a 2 by 2, and B is a 2 by 3. So the inside matches. That's a check mark. That means I can do multiplication. And this is the result. The result is a 2 by 3 matrix. Now, where you are determines what you're going to do. This is row 1, column 1. This would be row 1, column 2, row 1, column 3, row 2, column 1, row 2, column 2, row 2, column 3. So to find those individual pieces, I'm going to be pulling things. Like this is row 1, A followed by B. I'm going to grab row 1 from A, which is negative 1, 4, and I kind of turn it sideways to some degree because we're finding what's called the dot product. And then I'm going to find column 1 from B, which is 3, 2. And you're doing something called the dot product. It's not actually multiplication. We call it multiplication, but it's the dot product. And I'm going to multiply across. Negative 1 times 3 is negative 3. 4 times 2 is 8. And I'm going to add, and I'm going to get a 5. So in my answer, element 1 is a 5. And again, this was row 1, column 1. The next thing I'm going to do is going to be row 1, column 2. So still negative 1 and 4. And then column 2 is negative 4, negative 5. So if I multiply across, I get 4 and negative 20. And if I add, I get negative 16. Okay, moving on to row 1, column 3. Row 1 is still negative 1, 4. Column 3 is 7, 3. If you do this enough, you'll be able to do it in your head. You will. Define this dot product, negative 7, 12, add down, get 5. I'm halfway done. It's not that bad. So I've moved down to here, which is row 2, column 1. So now I'm looking at 2, 8. And column 1 is 3, 2. Multiply across, I get 6 and 16. When I add, I get 22. I've moved on to row 2, column 2. 2, 8. Okay, I seem to be wanting to grab columns over here. Column 2, negative 4, negative 5. 2 times negative 4 is negative 8. 8 times negative 5 is negative 40. Their sum is negative 48. And just about done. I am now sitting at row 2, column 3. Row 2 is again 2, 8 from the first matrix. Column 3 from the second matrix is 7, 3. 2 times 7 is 14. 8 times, supposed to be a 3, is 24. And I add down and I get 38. And there is my result. It's not necessarily a hard thing. It's tedious, and some of y'all can't multiply to save your life. But it's built on basic math. I guess I'll do number 3. This is find 3AB, and I will save this for last. Just trust me on that. Do A times B first. So A is a 2 by 2, and I'm going to multiply it by B, which is another 2 by 2, and the insides match. The outside tells me I have a 2 by 2 remaining matrix. And again, I'm labeling these positions. Row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. And I'm just going to find those bits and pieces. If a kid will label, take the time to label, it tells you what to do. So let's look at R1, column 1. Row 1 is 5, negative 3. Column 1 is 0, 4. The dot product here is going to be the sum of 0, 5 times 0 is 0, and negative 12. which is negative 12. Don't ask me why I put a little equal to symbol there. It doesn't need one. All right, moving on to row 1, column 2. Row 1 is still 5, negative 3. Column 2 is 1, negative 2. 5 times 1 is 5. Negative 3 times negative 2 is 6. The sum is 11. Okay, now I'm down at row 2, column 1. Row 2 is negative 2, 4. Column 1 is 0, 4. On the dot product, we got negative 2 and, we have 0 and 16. Sum is 16. Still off today, apparently. Finally, row 2, column 2. Negative 2, 4 for row 2 from first matrix. Column 2 is 1, negative 2. Negative 2 times 1 is negative 2. 4 times negative 2 is negative 8. And the sum is negative 10. So that is the product of AB. Now I'm going to do 3AB, which means I'm going to put a 3 in front of it. What's amazing is a lot of you are just going to copy down my answer. You're not going to copy down any of this work, which means I'm not going to give you any credit. None. This is the teaching stuff. So there's a 3 out front. It's essentially the distributive property, just 3 everything. We'll have a negative 36, a 33, a 48, and a negative 30. There you go. That's number 3 in all her glory. Now 4 is going to take me a little bit of time, but not too much time. See, I've already done AB. Haven't I? I've already done AB. AB was this guy right here, assuming I did it all right. I don't have time to go back and check. Hopefully some of y'all will try to figure it out. But I need to find AC. So when we talk about A times C, we still have a 2 by 2 and another 2 by 2. We're going to have a result that's also a 2 by 2. This is my AC work, okay? Again, positions matter. Row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. So row 1, column 1 starts with A. This comes from matrix A. Row 1 is 5, negative 3. Column 1 from C is negative 6, 4. That's negative 30 and negative 12. Their sum is negative 42. Now I'm moving on to row 1, column 2. Row 1 is still 5, negative 3. Column 2 is 3, 1. 5 times 3 is 15. Negative 3 times 1 is negative 3. Their sum is 12. Now I'm moving forward to row 2, column 1. Row 2 is negative 2, 4. Column 1 is negative 6, 4. Negative 2 times negative 6 is 12. 4 times 4 is 16. Their sum is 28. And finally, I'm moving on to row 2, column 2. So row 2 is still negative 2, 4. Column 2 is 3, 1. Negative 2 times 3 is negative 6. 4 times 1 is 4. Their sum is negative 2. So there's AC. Remember, our goal was to find AB plus AC. Our goal is to take AB, which we found to be negative 12, 11, and 16, negative 10, and add it to AC, which is negative 42, 12, 28, negative 2. And addition is like positions. Negative 12 and negative 42 is going to be negative 54. 11 and 12 is 13. 16 and 28, 42, I believe. Not 42, 44. And negative 10 and negative 2 is negative 12. Perfect. See, it's not that bad. It's not. I'm leaving 5, 6, and 7 for you. I'll start you out on 7. I'll start you out. This is like -3, 1, 4, 7, 0, -2, 3, 4, 1 times itself because you're squaring it. And this is going to be a 3 by 3 times a 3 by 3. Insides match. So you're going to have a 3 by 3 as a result. And you're going to have to do 9 things to get it because there's 9 elements in it. It's going to take you a minute. It ain't going to kill you. All right. I'm only going to do one of these. And I'm going to do number 9. So this is row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. So to get this y, I took row 1, which is 4, 1, and 3, and I multiplied it by column 1, which happens to be 9, 2, and -1. And I know when everything is done, it adds up to be y. That's how it works. I add and I get y because that's what's there. 4 times 9 is 36. 1 times 2 is 2. 3 times -1 is -3. So when I put all these numbers together, I got 38, 35. Y is 35. See, it's not that bad. It's really not. Now, let's think about getting x. This is row 2. All right. Here's something in row 2, column 1. So I'm going to take row 2, which is -2, x and 1. I'm going to multiply it by column 1, which is 9, 2, and -1. And I'm going to do some math. I know that the result is going to be -13. Okay? -2 times 9 is -18. X times 2 is 2x. 1 times -1 is -1. If I add these things together, I get 2x minus 19, but it has to equal -13. I add 19 to both sides, I get 6, and x has to be 3. Easy peasy lemon squeezy, kids. There's your matrix multiplication. So I did 1, 2, 3, and a half, because I didn't do that one. Or let's just call it 4. Out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 problems. I did 4/10 of your homework. It's pretty good, I think. There you go.